Welcome back to the Structural Engineering Podcast. This week we've got an episode I've really wanted to do for a long time, but admittedly wish I knew a little more going into it. I have to assume many listeners have heard of the SE 2050 Challenge by now, or the SEI's Sustainability Committee. Well, today we're talking with Megan Stringer.
My name is Megan Stringer, an associate principal at Holmes Structures.
And Erik Neer.
Erik Neer, I'm a principal with Holmes Structures, also based here in San Francisco.
Besides their role at Holmes Structures, they're heavily involved in advocating for a more sustainable built environment. Before diving into some of the resources they shared in this episode, I have to say I didn't think there was a lot we, as structural engineers, can do to lower the environmental impact of a building. Particularly, since I started out in the architecture world, there seems to be just so much more they can do to influence the final product. I was completely and happily incorrect. So with that, please enjoy our conversation with Megan and Erik. Let's start by understanding exactly what the environmental cost is of the structures we design. We've all heard to some extent that we need to reduce greenhouse gas emissions, and maybe your mind goes to efficient HVAC or architectural concepts like environmentally friendly finishes, solar orientation, whatever. But is there space in structures to have the same impact? And what impact do buildings even have in the big picture of carbon emissions?
There's a lot of different stats out there that I've heard, but I think the most common one that we hear is that buildings generate approximately a third of annual global greenhouse gas emissions, with a quarter of the building sector's emissions coming, just from the production of structural materials alone.
Let's look at that a little closer. If you were to take all of global CO2 emissions and break out contributions by sector, the thing we often think of as the worst contributor, transportation, only accounts for 23% of the pie. All of industry only makes up 32%. But with building operations at 28 and building materials at 11, the building sector as a whole turns out to be far worse than what we typically think of as our big polluters.
So when considering energy use in buildings, what are the standard metrics used for calculating these values? Does energy use per day capture the full picture?
No, definitely not. As buildings get more and more energy efficient, it used to be that operational energy dwarfed that embodied carbon over the life of the building. And so, there was some sentiments that, what we could do in terms of reducing the carbon impacts of the building was insignificant. But I think we've seen over the last 10, 15, 20 years, this huge drive towards net zero operational energy and zero carbon over the life of the building, and the role that we play as engineers to really make sure that we're maximizing, that total life cycle carbon is essential. And so I think, as we start to get into more complex LCA life cycle analyses, I think really looking at your total carbon, not just your operational carbon, but your total carbon inclusive of your embodied carbon, as well as any risks associated with that through long-term resilience, and what type of life cycle carbon impacts we need to invest, not in the operation of your building, but in the repair and maintenance of your building, such that the longer that you have a usable life of your building, that spreads that carbon investment out over that longer life. So I really think it's important to take that holistic building life view of your building, as opposed to a year by year, operational energy investment. I know, Megan, you've certainly done a lot of research and advocating for life cycle analysis in structural engineering. Do you want to add anything to that?
Just one other piece there is, I think when you've typically looked at the impact of a building, it's either coming from the operational impacts or the embodied impacts. And like Erik had mentioned, it was traditionally, 80% of that, the building's impact was coming from the building's operations. And so as that buildings have become more energy efficient, using clean energy, the embodied carbon, split has started to become much more significant. And I think a lot of those initial studies or LCA studies were also, assuming a 60-year lifespan of a building. And you have to take also into account that buildings are typically refurbished or even torn down within that 60-year lifespan. So it definitely starts to just hint at or suggest that, embodied carbon is a bigger piece of that pie than I think originally thought of.
If you're looking at a longer lifespan, what is that target like? Is that reaching out to 100 years?
I think it depends. I think it depends on the building and the client and the usage. Right?
Yeah.
As long as we can, the key part there, Megan hinted at, is most buildings don't get torn down because they're structurally deficient and deteriorated and a risk. They get torn down because they've reached the end of their useful life. And so I think as engineers, really focusing on with the design team and the client, what can we do to build in future adaptability into our design such that when it's not an office anymore or when it's not a clinic anymore, what could it become? And making sure that you are building the designs with large, open, easily reconfigurable spaces, so that down 50 years down the road, 60 years down the road, it can become something else. I think related to that, thinking about that cradle to cradle use of buildings is thinking about deconstructibility and how can we design and detail our buildings such that if and when it does reach the end of our usable life and does need to be brought down, how can we kind of reincorporate those materials, that investment, in carbon assets, back into new construction.
Erik is right on, of course. When looking at overall building life, going back to the 1950s, the average age of a building being torn down was 111 years old. By 2000, that number had dropped to 60 years in one study and 50 in another, and it's clear that number has continued to move farther and farther forward. I read a paper a while back talking about the material waste inherent in structures. Not exactly from bad design, but from trying to be economical with member choices. And from the fact that with steel and wood, there are really only discrete sizes available to us, and we're rarely able to get to our limiting DCR and fall somewhere under that. I wanted to ask if somehow making better design decisions can help us reduce material waste.
I think most engineers are focus a lot on efficiency of their structures. I think there's very few engineers that you'll find that do one beam design and do it across the entire floor and every level and roof simply because it's easier for them. I think most engineers are responsible charges of their clients' resources when it comes to that. I do think we can do a better job when it comes to material strengths and specifications. I think there's a really fascinating study that Megan led through the SEAC Sustainable Design Committee around concrete and high performance, low carbon concrete. And Megan maybe can elaborate on this in a moment. But I think one of the key takeaways there is there really isn't much difference from a carbon impact across 3,000 psi mix and a 7,000 or 8,000 psi mix. There's kind of bad mixes and good mixes across that full spectrum, and you can get double the strength at a pretty equivalent impact, and proportionally you're kind of better off. You're going to be using less material, using less concrete by specifying these higher strength materials. And so I think being really judicious how and where we utilize high strength materials, grade 80 rebar instead of grade 60 rebar. It's here, at least where we practice in the Bay Area, grade 80 is only 5% more expensive than grade 60 rebar, but it's 30% more efficient, right? So why wouldn't you use that where you can? Yet I think that's a practice that isn't very prevalent across. So there's really simple things I think that every engineer can do in their daily practice to leverage and maximize the use of the materials. And I think that comes more around to material specification than it does to optimization of design, which I think engineers probably generally do pretty well.
So you kind of touched on this a little bit, but we've kind of heard the saying that the greenest building is one that's already been built. And you kind of talked about that a little bit as repurposing structures. As we tend towards higher efficiency, or at least the ability to be, do you think that this will always kind of remain true?
By and large, I think extending the life of the buildings that are already built and not taking new resources and new energy to build new buildings is going to be more efficient in the long run. And there's been a number of studies. I know the National Historic Trust funded a study. I think that was entitled that same thing, the greenest building is the building that's already built, or something very similar to that. And so there's been some very compelling studies and analyses, showing that just kind of throwing away the impact of those old buildings, it has a significant environmental cost. We can't ignore the fact that new buildings are much more energy efficient than old buildings, however. And so, that's not to say we should stop building new energy efficient buildings, but 99% of our building stock is an existing building. So figuring out if we're trying to make big global changes, figuring out how we can extend and leverage those existing resources further, do energy retrofits on them so that they are higher performing energy systems. I think that's where the real big opportunities are. Building a single new, net zero energy building, while that's good and it's better than building an unsustainable building, that doesn't really move the needle on the things that we need to do to prevent climate change. We really need some broad actions that impact to these old buildings. And one of the things too is that, particularly when you're talking about much older buildings that were, pre 1920, 1930, before the advent of air conditioning, are actually pretty sustainable buildings because they have great daylighting, shallow footprints, operational windows with natural ventilation. They had to use those passive strategies because they didn't have the active systems that were there. So I think there's a lot of old buildings with a lot of good bones that we should certainly do more to take advantage of.
So getting down to design a little bit, and I don't know if this is an easy question or more complicated than it might seem, but when looking at materials that we use, which have the highest and lowest greenhouse gas emissions just in fabrication?
Now you're going to get us in trouble, Max. Now we're going to have
I got to point out a material, but you can't use that one.
Everyone's going to come after us. No, I mean, there's not an easy answer to that. And there's certainly been a lot of studies, and I think each lobbying organization for the materials will tell you something different. I think there is certainly a clear advantage to using renewable resources to build. And in that case, wood has a clear advantage. It's the only renewable resource that we build with. And obviously there's a big caveat there around sourcing from sustainably managed forests. And that might not be possible or feasible in every area of the country, right? If you don't have easy access to that, and shipping wood, to the southeast may not always be more sustainable than building something out of concrete or steel. So, it's dependent. It's a regional question. It's dependent on what sourcing that you have. There's obvious major challenges with sustainable concrete. And that's why I know Megan has focused a lot of her efforts in the last 5-10 years in finding and researching better ways that we can use concrete as engineers. It depends on who you ask, but it's anywhere from 5 to 10% of global greenhouse emissions are only from the production of Portland cement. That's one ingredient in concrete, right? So not all the rest of concrete, but just the Portland cement, is 5 to 10%, maybe more like 7 or 8% of total global greenhouse gas emissions. So we need to find alternatives to that. One of the challenges is obviously some of the alternatives we have right now are byproducts of polluting processes like coal-fired power plants. So that's not a sustainable solution. So I think it's something we're really, struggling with. And I think maybe, Megan, you can talk a little bit more about concrete and what we can do there. But I think if you can build with wood in a sustainably sourced way, that will almost always be your most sustainable building that you can build.
Yeah, I think I'll just add, even looking at all the materials, there's ways to make efficiencies within each material and choose better options, whether that's through, your specifications or whatnot. In steel production, whether it's using, basic oxygen furnace or an electric arc furnace is going to have a big impact. So we are seeing, a lot of strides being made in the environmental product declaration realm. And so that manufacturers are able to kind of do these LCAs on their individual products. And so that will give us as designers more knowledge to know what's the impact of this specific wide flange coming from this mill versus this other one. And so the hope is that as more producers are producing these for their products, us as designers will be able to have a lot more transparency and role to play and being able to get what we want and get the less impactful material. Relating to concrete, concrete's never going to go away, and we use it in every project that we build with. And so it's been really exciting to see all that's been happening in this low carbon concrete realm, and was just talking on a panel the other day about it. And I do think the concrete industry is stepping up and is realizing like, hey, mass timber is a contender in taking some projects that used to have gone, concrete. And so I think we have their attention, and they are rightfully stepping up to the plate.
I have a question that I've always wondered, and that is, how much wood, with wood being the most sustainable option, is available to us sort of on an annual basis? Like the amount of projects that we are doing in wood, how much more can we be doing and still be able to sort of take in that as a renewable resource?
Do you have those metrics in hand,
I was
Megan?
like, there's some really cool
Yeah.
metrics out there.
I know.
Like,
I've seen some amazing presentations by the others in the wood industry. And I know Woodworks is a great resource for information around mass timber and wood use. So I'd highly encourage everyone to check out their website. But one of the interesting persuasive arguments that I've seen about this is right now, when you look globally, one of the huge problems we have with climate change is deforestation, right? And right now we are incentivizing people across the world to take forests down and for pasture lands or agriculture because it is more economically beneficial for them to do that. You know, those pastures are worth more than the trees. And so one of the arguments around this push towards large scale commercial mass timber construction is let's make trees valuable, right? And so the more that trees are in demand and that wood is demand, the more those forests will be worth and the more the forests that will be planted to serve those needs. Now, again, there's this big caveat around proper sustainable forest management and certifications like, FSC and SFI, help to provide guidance to how to do that properly. But, I think there is a very compelling argument that the supply should grow to meet the demand, and that growing supply means more trees in the world, which is a good thing for our fight against climate change.
Megan, to kind of elaborate a little bit more here on concrete, with it kind of being one of the worst materials, let's say, thinking about more of a green building, are there currently viable alternatives out there?
As Erik had kind of alluded to, is at least for certain buildings of a certain height and whatever, mass timber is kind of going to be that other alternative or an alternative out there that we have that can compete. Obviously, there's some provisions around, the height of the building when it's in mass timber, and there are, some forthcoming tall timber provisions that are getting adopted by the IBC and are already actually adopted in some cities and states. Thinking about your concrete structure, how could you then go about designing it with a lesser carbon footprint? So yeah, getting into the whole low carbon concrete realm. And so also talking about SCMs and looking at how much cement replacement we can get and noting that fly ash and slag are like byproducts of a very energy intensive operation, and that's not really a long-term solution. So, utilizing it now while we can is great. And I think, the biggest strategy is how can we get the cement out of concrete? And so there's other strategies out there relating to like carbon sequestration. And I'm sure you guys have probably heard, or maybe you haven't, of CarbonCure, but that is a readily available carbon sequestration technology, at least in the Bay Area and in lots of other places across the country. And it takes you one step closer to reducing the carbon, basically the cement out of your concrete, and therefore lowering the embodied carbon. And I guess I know concrete does kind of get a bad rap. You got to look at your buildings holistically, and so concrete offers a lot of great properties from like all the thermal mass capabilities that it does have, and long-term durability, and if you're comparing deflection and vibration of a concrete slab versus a mass timber slab, these things do need to be taken into account to really get better comparisons.
As an engineer, trying to always have some backing with some sort of code or some provision of, is there currently concrete mixes or design methodologies out there to have a more sustainable concrete mix?
Yeah, I'll take a go at that. I think one of the ones that Megan mentioned, I'm really excited about, the CarbonCure, in situ carbonization of the concrete is a really exciting technological advancement. Less so for the fact that we're injecting carbon into the concrete, which is cool, but the impact of that embodied carbon or the injected carbon is fractional compared to the offset that you get when you reduce the amount of Portland cement. Because what happens when you inject the carbon into the concrete is that calcifies and creates like an artificial limestone, within the concrete as it cures. And so that it hardens the concrete and makes it stronger. And so because that makes it stronger, you need less Portland cement to get up to your design strength. So those reductions by reducing the Portland cement are orders of magnitude more in terms of CO2 reductions and carbon reductions in your mix than the carbon that's put in there. So, I think, those, and what's most exciting about that is that at least here in the Bay Area, it's offered cost neutral. There are no added costs for that. So you could specify a low carbon mix at the exact same price that you specify a standard 15% fly ash replacement mix. So, there's really no reason, at least in those markets that have this technology, why you shouldn't be doing that on every single project that you're working on. There's also, coated aggregates that can help to, minimize and reduce the carbon in your concrete. There's also just more old-fashioned mix design things that you can do with high volume replacement mixes. So things like, if you're worried about early strength gain of a high volume fly ash replacement mix, if you're trying to go 50, 60% replacement, lowering your water to cement ratio can significantly improve your early strength gain. So you don't have to specify a 56-day strength. But even in that, I'd really ask and challenge engineers, do you need 28 days, right? I just did a project where we actually specified a 90-day strength. We didn't specify a 28-day strength because we didn't really need a 28-day strength. It was a post-tensioning project. We had a 50% replacement on our post-tension decks. We had a 3-day strength and a 90-day strength, and that's what we specified. And it was a very cost-effective mix that was as cheap as any of the other options that were out there. So I would, challenge engineers in your specifications. What do you really need? And also have the conversation with your suppliers about what they can provide. Because I think, at least here in the Bay Area, maybe it's different across the country, but you'll find most of them are willing and interested to have that conversation with you about, here's what you really need. Here's how we can provide a more efficient and more sustainable mix to you at very little to no extra cost.
I think in specs, it's too easy to just copy and paste, on and on to the next project, and just taking that time to think about what is actually necessary in the project can really benefit quite a lot. I want to ask about the term LCA, come up a few times. For, a simple engineer like myself, could you tell me what that is?
LCA is essentially, think about it as environmental accounting. So it's accounting for all the inputs and outputs that go into a product, and the product in our case is a building. And so your life cycle assessment, takes into account everything from just the very beginning of your building, from raw material extraction and the energy and use that it takes to turn those raw materials into structural materials and manufacturing those. It takes into account, any transportation impacts and, the building's use while it's being operated. And then lastly, it takes into account the end of life impacts. So the impacts from the demolition and disposal of the building, or the demolition and recycling of the building. So it's just, essentially a way to scientifically calculate an impact of a building throughout the whole phase of a building's life.
Okay. In what way is LCA information sort of available to structural engineers? Is there kind of a rating that we can get to, or how do we know what those numbers look like?
Yeah, so that's a really great question. And it kind of focuses around what we kind of term like benchmarks. So there's been a lot of like, how do you know what a benchmark office building is? What should I be targeting from, we talk a lot about global warming potential, but that's just one of the metrics that an LCA measures, but it's the biggest. So, there's lots of talk of how do you know, where you're at and where you should be at. And so what we're hoping with this whole SE 2050 commitment program effort is that by having structural engineers submit embodied carbon data to a database, that we would then be able to, once we get enough data in that database, be able to set some benchmarks out there so that engineers would be able to essentially look up like, office building or hospital or school. I don't know how granular we'll make it, whether it'll be different regionalized or not. But anyway, more to come on that. But I think there is some guidance out there. There was a document put out by the SEI Sustainability Committee looking at guidance on whole building LCA and reference building. And so you can find that on the website, and it just kind of takes you through just some guidance on how engineers should really be framing that reference building.
There's a concept used in sustainable design known as Environmental Product Declaration, or EPD. An EPD is an independently verified document that communicates information about the life cycle environmental impacts of products. These are presented in a way that multiple products can be compared on an even playing field. Megan helps us understand exactly what these mean and how we can use them to make better building choices.
Pretty much all the main structural materials have an EPD. Sometimes they are only industry averages. And so, for example, there are concrete industry averages that have been put out by the NRMCA, and there's steel industry averages as well. Obviously, those are great. And usually, it's just a certain percentage of their plants or mills have submitted data. I mean, that's kind of how they've created these industry averages. But what's more exciting, I would say, is probably these manufacturer-specific EPDs. So there's been a lot of concrete suppliers in this area creating EPDs for all of their mixes. And so we've already been seeing them coming in with our typical concrete submittals, and they'll just be like one data sheet that just gets submitted a lot of times, even if it's not requested by the engineer. And the same is going for steel and other products as well. The committee did toy with an idea of trying to come up with a database or a repository so engineers could go in and actually see where, what EPDs are out there. I think the EC3 tool is a good EPD repository right now. If you wanted to download that and look at that, you can kind of see what's out there. But yeah, I guess you'd have to do some Google searching to find them. But there are industry average out there for all of the main materials.
What other ways can we be more efficient with materials we're already using? Where do we have the most leverage? You've kind of touched upon a few, but are there any others that come to mind?
Yeah, I mean, there's so much exciting work happening right now, I think, across all of the material parts of the industry. I think certainly with concrete, there's all the strategies we've talked about. But even things, like, using post-tension concrete more, right? Or looking at leveraging precast post-tension elements. I think even things like looking at how offsite construction can save materials due to reduced waste that occurs when it's done in the field. There's composite systems and hybrid systems that are being developed with steel and timber and, concrete and timber systems. So there's so much work being done, I think, across the board. Everyone's looking for new opportunities and how to squeak out advantages and efficiencies in their systems. So I think there are endless opportunities for us as engineers to be engaged with our industry partners and really find and understand what systems are going to benefit the project. I mean, there's sort of small things and big things. I think the big things are exciting, using the new mass timber systems or, the composite hybrid beam systems. Those things are attractive and they're maybe easy to sell to a client and architect. But there's the little things that Megan and I have talked about, things that you can do on every project, whether it has a sustainable goals or not. Again, things like cambering your steel beams, right? Not every engineer does it, although we probably should, just to make it more efficient. And things we talked about specifying higher strength materials and rebar and concrete strengths. So I think, yeah, there's kind of a myriad of new systems opportunities that we can use to create more efficient structures and leveraging offsite prefabrication techniques to reduce waste, things like advanced framing. If you're doing light frame timber construction, that make really efficient use and use 30% less wood in your building, just through smart detailing, as well as preventing thermal bridging. So you have a more energy efficient building as well. We can kind of go on and on with that. I think it's important to just note that there are probably a lot of the small things, can often add up to be more than some new flashy, exciting, system.
One thing that you said kind of made me think about something else was really about this offsite manufacturing. I've been working on a lot of projects lately, really focusing on almost like how do you take out a lot of the time and energy of constructing certain things on site and take that off site into this pre-manufactured realm. So how are we integrating our services into our structural floor sandwiches, for example, and really trying to tackle that and really looking at, building some type of floor cassettes or something that's going to be integrating in a bunch of different things, not just the structure, and then be able to ship these larger items to site that just then get, craned into place. And so I think buildings start to progress, we are going to hopefully start to see some technological advances and some advances in how we're building things. And I think that integration between consultants is going to start to play a bigger role.
There's a buzzword in structural engineering that I think we've been hearing a lot recently. This is resilience. But there's clearly an overlap between a resilient structure and an environmentally conscious building. How do you see these two concepts interacting?
There's obviously a natural synergy between resilience and sustainability. I think both are, take the long view, right, of the building and really look at its performance over the long term. Sustainability historically is focused more on, energy performance. But I think, really with the advent of LEED version 3, that was 10, 12 years ago now, it's been a while, but there's been this shift towards really thinking more about regional impacts, life cycle assessment, and really the performance of the structure as a whole over its life. And, when you start talking about resilience and resilience to natural hazards, I think that, those two go hand in hand. What you're talking about is how is this building going to behave over its life, and how can we minimize the impact and damage to that? And those impacts and those damages are directly translatable to environmental impacts. And so I've done a number of papers and research throughout the years that I think is attempted to tie that specifically to how do we generate the tools for engineers to really combine the two sciences that we have of probabilistic hazard analysis to say what's the risk to this building over its life from a seismic event or a hurricane or a flood, and how do we measure and define those losses, and then convert that through like an economic input output LCA analysis to say, okay, here's the value of those damages in these systems. Let's convert that to environmental impact. And then we can really measure and design and check for those sustainability impacts as well. So there really is a one-to-one tie between damages due to natural hazards and environmental impact.
So you brought up a few times while we've been chatting about the SEI 2050 challenge, or 2050, and there's the SEI 2050 challenge that serves as a guide for a more sustainable structural future. Can you tell us more about this?
Sure, yeah. So, let's clarify. So there is the SE 2050 challenge that was issued to the structural engineering profession in the summer of 2019 to our profession that stated all structural engineers shall understand, reduce, and ultimately eliminate embodied carbon in their projects by 2050. And so kind of right around the time when they were incubating this whole idea of the SE 2050 challenge, they approached the SEI Sustainability Committee, just noting that SEI was, is basically the leading national professional organization for structural engineers out there, with this effort or with this idea of coming up with the US's answer to that challenge. And so, this is very similar and paralleled off of the AIA and Architecture 2030 challenge and commitment program. And so, so we've been developing the SE 2050 commitment program within the SEI Sustainability Committee for the last couple years now. And the program just went live in November. We've already had 20 firms committed, which is super exciting. Firms of, all size and all locations across the country. So very uplifting and makes me very enthusiastic. And it is really a great time to be in our profession. And so this commitment program is essentially something that structural engineers would sign on to, or structural engineering firms would sign on to. They would need to start by getting a letter of commitment by their firm's leadership, and then agree essentially to create two things. So to create an embodied carbon action plan within the first 6 months. So really in this plan, we're really just hoping that firms will take a look at what they plan to do in this space and how they would really look at getting, reducing embodied carbon in their structures. So very easy, low-hanging fruit things, just like educating their firm on embodied carbon reduction. And, we're providing a lot of tools and resources out there for firms to be able to do this, et cetera. And so, trying to get those plans in the first 6 months of committing, and then basically the last requirement of committing to this program is agreeing to submit a certain number of project embodied carbon data. And I think the most that we would be requiring of any firm, depending on how large, for the larger firms, is five projects per year. So pretty low barrier of entry, and that was intentional. I definitely think as this program progresses, things are going to get a bit more stringent, and that's the intent. And so right now, we're not telling you to reduce your embodied carbon of structures just yet. We're just trying to get people used to tracking material quantities, plugging that into an LCA software, and then seeing where they're at from an LCA standpoint. But as time goes on, we would definitely be setting limits and reductions on embodied carbon for buildings, and maybe requiring more building data to be entered.
If someone is working for a firm and the firm doesn't necessarily get behind this, is there a way to participate just as an individual in SC 2050 in any way?
Yeah, there's obviously ways you can get involved with the committee if you're so prone and inclined. We're always looking for people with enthusiasm and energy to put towards the committee. So that's one way. But then obviously doing a lot of these things that Erik and I kind of mentioned throughout this whole talk is, there's lots of ways that you as a designer can make an impact regardless of what your firm's doing. Now, obviously, things like general notes and specifications are usually a firm-wide decision, but maybe there's some wiggle room and some play that you could have with that at your specific company.
So you guys gave a talk, and we reached out after this. This was a couple months ago, and so a lot of the questions we're asking kind of came from that. So sort of similar to what we talked about. And after that talk, one of my coworkers, we had watched this together, and he stood up and said, well, sounds like it's not really a structural problem, right? It's not on us to fix. It's just for architects and developers. And it felt, one, like, what is it? No. But, I think he might be coming from the side of, if we are looking at resiliency or performance-based design, like the best maybe we can do is say, hey, owner, this is why you want to make these decisions, but, then it's almost it. We can't actually force this upon someone. We're not in control of the money in that sense. What would you have to say to, engineers that have this mindset?
I mean, I think they're completely wrong, to be honest. I think the time is now for our profession to really step up, and it's an exciting time. I think until recently, these last couple of years, embodied carbon is finally seeing, its time, it's being daylighted as an issue. And I think we don't step up as a profession and take on embodied carbon reduction, that someone else is going to do it for us. And I don't think we want to be in a position where architects are dictating things in our concrete mixes to us. And I really think that they're going to take this on it if we don't step up and do it ourselves. And I think, we are in the best position to do that. And it's in that sense, I do think it's an exciting time. We're seeing a lot of change, and a lot of owners and architects coming to us and talking to us about sustainability and what can we bring to the table, and asking us about carbon cure. And so it's been an exciting time. We're finally getting asked to add LCA into your proposals, and I think that definitely hasn't been the case.
I agree with Megan, not surprisingly there. I think, that perspective is probably people that are looking for ways to not make this their problem, right? But it's all of our problems, and we need to really engage a huge majority of engineers out there to make it their problem, and realize that there's a lot we can do, and there's a lot we can do unilaterally, as we talked about. There's things that we can do in our specifications and in our design that don't require the approval of the owner, that have small changes but have big effects. And so I think really taking the time to educate ourselves as a profession on what those things are, is going to have a huge impact. But even on the bigger issues, I think it's important not to lose sight the role that we play on a design team, I feel that there is a certain mystique to the structural engineer in a design team, and that what we do is so objective and focused and specialized that most owners, when the structural engineer says something needs to happen on the project, don't question it. They say, that's what my engineer says, that's what I'm doing. And that's not to say that we should abuse that privilege or that position. I think that is a earned trust that we have, right, with our clients, and being responsible stewards of their resources and their design. But the point is that when a structural engineer speaks on the project, people tend to listen. And so I think, we have a platform, and I think we haven't been using it. I think there's been a missed opportunity for us to really be vocal proponents of sustainability, in large part because I think the early adopters of this, the visionaries of this, were the architects and maybe the mechanical designers, right, who have pushed this. And we kind of came into this late in the game, and I think maybe missed that opportunity. There's a perception that, oh, this is an architecture thing and this is a mechanical thing. But really, we are uniquely positioned and have a platform on our teams and in our industry to really promote meaningful change. So I would challenge anyone with that idea that we as structural engineers can't do anything, and really encourage them to look at all the really powerful ways that we can have an impact.
That's it for this episode of the Structural Engineering Podcast. There are a lot of links mentioned here, so we'll try to get as many as possible down in the show notes. As always, please reach out with any questions or episodes you'd like to hear. Thanks for listening.